these four types of angles, right? And we talked about what they are, how to identify them. But today we're going to add one more statement to it, and that's going to help us to kind of help us with the angle measures, okay? Because yesterday we didn't really talk about angle measures a whole lot because of one thing, okay? As I look at this picture, what do I notice about P and Q? They're parallel. How do we know that?
They never touch.
How do we know they never touch? The arrow, right? And we're not talking about the arrows on the ends of the line. We're talking about this red arrow right here that's in the middle or on that line, okay? So the most important thing right here is that P is parallel to Q, okay? And we're going to talk about that right from the start here. If P is parallel to Q, which it is in this case, okay, P and Q are parallel to one another, and we know that without a doubt because of the arrow that's on those two lines, then we're going to talk about the relationship of all of these. And we kind of saw it yesterday where we have 8 angles in here, right? And if I tell you that angle 1, and I'm just going to make up a number here. If I tell you that angle 1 is 120, by knowing that one angle, I can find all 8 angles in the picture, okay? All I got to know is one angle. I can find the other 7 from that one if these two lines are parallel. Okay, so the first relationship we're going to talk about is angle 1 and angle 5, or angle 2 and angle 6. Well, yesterday we identified those as being corresponding angles. Darston, do you have your notebook?
Yes.
Okay, so in this case, what we're going to say is angle 1 and angle 5 are corresponding. Okay, what do you think would be true about angle 1 and angle 5? Anybody want to take a guess? They what? Okay, they are the same angle measure. Okay, so this would also be 120. And so we are going to say that those angles are congruent. 2 and 6 would be the same way. Now, I told you we could find all 8 of these, right? If this is 120, what do you think angle 2 is going to be, based on what we've talked about earlier in the year? What do these two together do? They make 180, right? They make a line. So if this is 120, the guy right next to it has got to be 60. And if angle 2 is 60, then what do you think angle 6 is going to be? 60. Because these two are corresponding, angle 2 and angle 6 are corresponding angles will always be congruent. Okay? All right, the next one. We talked about this pair yesterday, alternate interior angles. Alternate interior angles are angles 3 and 6 or 4 and 5. So we're talking about 3 and 6, 4 and 5. Okay? So a couple of different things we can talk about here. If this is 60, what do you think 4 is going to be? Or what do we notice about 1 and 4? Think about all the relationships that we've got here. They're vertical, right? And what do we know about vertical angles? They're the same. They're congruent, right? So what I'm going to do here is I'm going to go ahead and fill this whole picture in. Okay, and I'm putting that angle measure in there. Okay? So as we look at 6 and 3 and 4 and 5, what would we say about those angles? They are what? Well, they're alternate interior angles, but what word am I going to use here? What kind of relationship do they have? What's true about angle 3 and angle 6? Don't overthink it. They're the same, okay? And what's the word we want to use for that? Congruent, right? They are congruent. They are the same measure. Okay, As we talk about alternate exterior angles would be angles like 1 and 8 or 2 and 7, okay? And they gave us examples of both of those. What's true about angles 1 and 8 and 2 and 7? Look at angles 1 and 8. Angle 1 is 120, angle 8 is 120, right? So what are we going to say about those two? Congruent, right? They are the same angle measure. So once again, they are congruent. So the first three relationship of angles are all congruent. Corresponding alternate interior, alternate exterior angles are all congruent. Okay? Now, the fourth one, consecutive interior angles. Consecutive interior angles would be like 3 and 5 or 4 and 6. What's the relationship between 3 and 5 or 4 and 6? Let's look at 3 and 5. Are they congruent? Are 3 and 5 the same angle measure? No. Okay, they are not congruent. What's true about angle 3 and angle 5 here? They make up 180. So what's the word we supplementary? Okay, they are supplementary. Okay, they make 180. Okay, so that's the relationship that will always hold true as long as P and Q are parallel. If P and Q are parallel, those relationships will always be those same. 3 of them are congruent, 1 of them is supplementary. Okay, so let's look at, based on what we just talked about, let's look at these couple of questions. Measures of 3 of the numbered angles are 120. Okay, identify the angles, explain your reasoning. Okay, so what's another angle? What's one other angle that would be 120? 4. How come? Okay. And I want to use a reasoning here as to like what type of relationship do they have. So what kind of relationship do these two angles have? What do we say they are? When two angles are directly across one another like this. They are opposite from one another, but what the word we're going to use here is they are vertical angles. And vertical angles are always congruent. Okay? Another thing to notice here is that these two lines are parallel. Okay? We see this arrow again. That arrow tells me that they are parallel. Okay? So that is absolutely critical to everything that we're going to do today. If those lines are not parallel, we don't know that any of this relationship will hold true. Okay? So that is extremely, extremely important to what we're doing today. Okay, so we said that angle 4 would be 120. What would be another angle that would be 120? Okay, angle 8. Okay. And then we have to say why. How do we know angle 8 is supplementary? Or sorry, congruent. Alternate exterior, okay? So I'm going to use alternate exterior to the original. Alternate exteriors are congruent, so because it's an alternate exterior angle, then it would be the same measure. Okay, and then we need one more angle. That would be 120. Okay, angle 5. Okay, and what's the relationship between the original angle and 5? What do we call these two? Corresponding. Okay, so here we would say it is corresponding to the original. Okay, so you don't just want to say because it looks like it, right? Just because it looks like it doesn't mean it's 120. We have to have a relationship. We have to have parallel lines. Typically here we probably would say something about there being parallel lines, but because the lines are parallel, then we know a little bit more about what's going on. Okay? Is there more than one way to answer this question? Well, let's think about this. If I said angle 8 is alternate exterior to this, angle 8 is also corresponding to 4, right? So I could say something like angle 8 is corresponding to angle 4. Okay? I could say angle 4 and angle 5 are alternate interior angles. So there's a lot of different scenarios I could use here, right? And so I could say angle 4 and angle 5 are congruent. So once I found 4, I could have used 4 to find 5, right? So I'm just giving you a couple scenarios. So can we answer this a lot of different ways? Is there more than one way to answer this question? When I give an explanation, what if somebody would have said angle 4 and angle 5 are congruent because they're alternate interiors? That would be perfectly fine, right? So just know that when you answer it, there might be more than one way to do it because there's all kinds of relationships happening in this picture. But the first and most important thing is that these two lines must be parallel to be able to do anything. Okay? If they're not parallel, then we don't know anything, essentially. Okay, let's go to the next page. The corresponding angles theorem. Okay? But here's the deal, guys. Like, I'm not going to ask you to remember the name of all these theorems. Okay? So what I'm going to teach you to probably do is instead of reciting the name of the theorem, I think it's just better to say exactly what we're doing. Okay, so we kind of have to go through this in a roundabout way. Is there any relationship between x plus 5 and 115? Are those any of the four relationships that we talked about? Are they alternate exterior? No, because this is outside, but this one's inside, because it's between the two lines, okay? They're not alternate interior, because this is inside, but this one's outside. They're not corresponding. So they're none of those relationships, right? What could I determine about angle 4? What do we know about angle 4? Okay, how come, Ryan? Vertical angles, okay? There it is again, okay? Vertical angles. Vertical angles, I told you guys last week when we did vertical angles that we are going to see that over and over and over again, okay? When I see two angles directly across from one another like that, I can immediately determine that they are congruent because they're vertical angles, okay? And so I would say angle 4 equals 114 because vertical angles are congruent. Okay, so if I tell you that this is 115, then what is true about these two angles? What'd you say? Okay, yeah, this angle has to be 65, right? And these two together would make what? They're supplementary, right? So there's a couple different ways that you could set it up, okay? But the way I'm going to set it up for right here is x plus 5 plus 115 equals 180. Those two angles added together equal 180, okay? Now, you could do like what we were talking about here. We could identify this as being 65, so I could just say x plus 5 equals 65. That would work the same way. But I'm going to show you why we get to that point, because if I subtract 115 from both sides, I get 65. And then I subtract 5 more, and I get x equals 60, okay? Now, here's what you got to understand. 60 is not the angle measure, guys, right? 60 is x. It's a value of a variable. So we're not trying to find the angle. We're trying to find x. Those are two completely different things. Make sure we understand it, because I think that's one thing that gets confused more than anything else. Are we trying to find x, or are we trying to find an angle? Okay? All right, let's look at the second one here. Do these two have any type of relationship? The two expressions that were given, do they have any type of relationship? Any of the four relationships that we've talked about? Okay, so alternate exterior would be this one and one. Right.
Same exterior.
What'd you say? Okay, they are the same exterior, but that's not one of our relationships. Okay, so you're right, they are both on the same side or are both on the outside, but we don't have a relationship that says anything about that. Okay, so the one we do have something, we say something about is alternate exterior. Okay, so can I find angle 1 here? Yeah. What's true about angle 1? I'm just covering up the bottom. Let's just focus on the top part here. What do I know about angle 1 and 136? They make a line, right? These two together make a line. So because they make a line, in order to find angle 1, I can do 180 minus 136. Okay? 180 minus 136 would be? .44. Okay, so angle 1 equals 44 degrees. Okay. What would be true then about these two angles? What do we call those two? Okay, and what do we know is true about alternate exteriors? As long as these two lines are parallel, so that's another thing you've got to make sure we check. Make sure they're parallel first. As long as these two are parallel, these two angles will be congruent, right? Alternate exterior angles will be congruent. One thing that you guys will continue to notice is over and over and over again, we are going to be using algebra, right? We've got to be able to solve equations. So we're setting up equations, we're solving for x. That's a common theme we've seen all throughout the year. So here we're going to subtract 9, and we're going to divide by 7. And we get x equals 5, okay? And that's what the question's asking. It's not asking us to find the angle measures. It says find the value of x, and that's what we've done, is we found the value of x, and that's our goal. Okay, so be careful on big ideas today to what they're asking you to do. Are they asking me to find x? Are they asking me to find an angle? Make sure you read the directions carefully to what you're trying to find. Okay, we didn't have a proof yesterday, but today we get to do a proof. Not have to, get to, right? There's a big difference there. I know you guys had so much fun with them in chapter 2 that we said, well, might as well do some more proofs, right? All right, so here we go. Prove that if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. Okay, so here's the deal. We have to prove, what we're proving here is why alternate exterior angles are congruent. Okay, what are we proving, Darston? Okay. So what we have to do is we can't say alternate exterior angles are congruent because alternate exterior angles are congruent. That doesn't make sense, right? We're proving why they're congruent. We know alternate exteriors are congruent, but in this proof we're proving why that works. Okay? So, first up, P is parallel to Q.
Hey, you're welcome.
Thank you.
You're welcome.
Okay, our first step's always our given step. Notice what it says here. Given P is parallel to Q. Okay? And my first step says P is parallel to Q, so what's my reasoning going to be? Given, right? That part hasn't changed. Almost always our first step's going to be given. We haven't seen anything different yet. Okay. We're trying to prove angle 1 and angle 2 are congruent, but we can't say anything about alternate exterior angles in order to do that. We have to prove why alternate exterior angles are congruent. Okay, so angle 1 and angle 3. Let's look at angle 1 and angle 3. What kind of angle pair is angle 1 and angle 3? corresponding, okay? And what do we know about corresponding angles? They're congruent, okay? So here's what we're going to say. There's a couple different ways that you could say this. You could say here, okay? So instead of saying the corresponding angles theorem, I would say if P is parallel to Q, then corresponding angles are congruent. We're stating what the corresponding angles theorem says. I know it's a little bit more writing, but at least we have a little bit more understanding of what the corresponding angles theorem is. If I just say corresponding angles theorem, what do we mean? What are we talking about? I think it means more if we say what we're talking about. And notice how we're writing our statement. It's an if-then statement. Okay, we're going to continue to see that a lot as we go through. Whenever we see a theorem, most of these theorems are going to be written in that if-then form that we did in chapter 2. Okay, so we know now angle 1 is congruent to angle 3. Why are angles 2 and 3 congruent? They're vertical angles, okay? And so I'm just going to simply say vertical angles are congruent. Okay, here's another big difference. Okay, for this one, for 1 and 3, I had to say something about the parallel lines. Because in order for corresponding angles to be congruent, we must have parallel lines, okay? Do we have to have parallel lines in order for these two angles to be congruent? If I covered up this line, and I didn't even have another line up here, would 2 and 3 still be congruent? Yeah, so do I need to have parallel lines in order for vertical angles to be congruent? No, so we don't need to say anything about parallel lines, right? I can just say, I know vertical angles are always congruent, okay? And that is as simple as our statement needs to be. We don't have to say anything about parallel lines, because parallel lines has nothing to do with vertical angles, okay? Step 4, okay? This one's already kind of laid out for us, which that's kind of nice, right? All we have to do is provide the reasonings. So why would angle 1 and angle 2 be congruent without saying that they're alternate exterior angles? Because we're trying to prove alternate exterior angles are congruent. So use the statements that from 1, 2, and 3 to come up with a reasoning here. Think about things that we've used. Why can we say angle 1 and angle 2 are congruent? Can't say that though. We're trying to prove why alternate, so we can't use alternate exterior to prove alternate exterior.
Is it because 1 is congruent to 3, and 3 is congruent to 2, so that means 1 and 2 have to be congruent?
Okay, you know what property that is? Remember what property that is?
Intransitive.
That's good. That's exactly right. Because they're both congruent to 3, they are congruent to one another. The transitive property of congruence. Okay, and so the reason we can't use alternate exterior angles is because that's what we're trying to prove. Okay, if we see a plane in the sky, I say, there's a plane. I know that's a plane because it's a plane, right? Well, if somebody didn't know what a plane was, they wouldn't be able to describe it, right? And so we can't use something to prove something that we don't know anything about. So if I say prove the alternate exterior angles are congruent, we can't use alternate exteriors to prove alternate exterior angles, okay? And so that's why that's a little bit different, but you can't say anything about this in order to prove. But because angle 1 and 2 are alternate exterior angles, now we know that forever those two will be congruent. That will always hold true. And now we know a little bit as to why. Okay. And this one here. Okay. We see angles in a lot of different scenarios in life, okay? Angles are used for a lot of different things. We'll see some different scenarios and situations where angles are used for a lot of different things as we go throughout the year. We eventually get into some trig stuff later in the year where we use a lot of different angles. But for right now, we're just seeing kind of what this relationship is and what are some things that we can use. So it's talking about sunlight enters a drop of rain. When sunlight enters a drop of rain, different colors of light leave the drop at different angles. The process is what makes a rainbow. Okay, for violet light, angle 2 equals 40 degrees. So I'm going to write angle 2 is 40 degrees. Okay, can we find angle 1? Okay, so here's the first thing. We always have to look for what first today? Before we ever look for angles or anything else, what do we have to determine? If we have parallel lines. Do we have parallel lines? Yes, okay? And right here, these two symbols are the key, okay? If those two lines are parallel, what kind of angles are 1 and 2? Alternate interior, okay? And what do we know about the relationship of alternate interior angles? They're congruent, okay? So we're going to say angle 1 equals 40 degrees because if we have parallel lines, then alternate interior angles are congruent. Okay. So we're writing our statement, we're writing our explanation or our reasoning out as an if-then statement. If this is true, which it is, okay, we do have parallel lines, then alternate interior angles must be congruent. Okay, but I can't stress to you how important it is that we have parallel lines, because eventually, as we get later in the chapter, there's going to be times where our lines are not parallel, or they're not identified as parallel, so then none of these relationships would necessarily hold true. Okay? All right.